In this video, we are going to discuss few problems on application of residue to evaluate real integrals. Problems based on the type contour integration, integral 0 to 2 pi f of cos theta, comma sin theta d theta. In this type, modulus of z is equal to 1. Before we start to solve the problem, first you should remember some basic results. If we know the results, we can easily simplify the problem. Okay, first we have to take modulus of z is equal to 1, and then we can write z is equal to e power I theta, and also we know that z is equal to cos theta plus I sin theta. 1 by z is equal to, we can write cos theta minus I sin theta. If we are adding these two equations, we get z plus 1 by z is equal to 2 cos theta. In the left hand side, if you are taking cross multiplication, it will be z square plus 1 by z, and then we can write cos theta is equal to z square plus 1 by 2z. Okay, first result. And then subtract from this to this equation, z minus 1 by z is equal to, we can write 2y sin theta. Taking cross multiplication in the left hand side, it will be z square minus 1 by z will come, and also we can write sin theta equal to z square minus 1 by 2iz. Okay, second result. And also z is equal to e power I theta. If we differentiate this one, dz by d theta equal to, differentiate with respect to d theta, dz by d theta equal to e power I theta into I will come. Now we can write d theta equal to dz by I into e power I theta. We know that e power I theta is z. Then we can write dz is equal to dz by iz. Okay. In this topic, the first thing is you should remember cos theta value, sin theta value, and also d theta value. If we know these three results, we can easily solve the problem in type 1 in the interval 0 to 2 pi. Okay. Using this substitution, we can convert into the simple closed curve problem, and then we can easily solve the problem. Okay. Evaluate integral 0 to 2 pi d theta by 5 plus 3 cos theta. We know that z is equal to e power I theta. From this we can write dz by d theta equal to I into e power I theta, and also we can write d theta is equal to dz by iz. Only you should remember this d theta value only enough for you. And also we know that cos theta is equal to z square plus 1 by 2z. In this problem, we are going to use these two results only. Okay, cos theta and d theta. The given problem is integral 0 to 2 pi d theta by 5 plus 3 cos theta. Using this substitution, we can convert into the simple closed curve form, which is 1 by 5 plus 3 into cos theta. Cos theta is z square plus 1 by 2z into d theta. D theta will be dz by iz. Okay. Now, taking cross multiplication, it will be 10z plus, here 3 is, this 3 is common for both the numerator term. It will be 3z square plus 3 divided by 2z will come into dz by iz is there. Now we can remove this z. The denominator 2 goes to numerator. It will be 2 divided by 10z plus 3z square plus 3 into dz by I. Okay. Here 2 by I constant, take outside. 2 by I integral over c dz by 10z plus 3z square plus 3. Okay. Now we can rearrange the equation like 3z square plus 10z plus 3 form. Okay. Now from this equation, take outside 1 3 common, because the coefficient of z square is here 3. In case if we have here 1 means we can easily simplify the equation. Integral over c dz by z square plus 10 by 3 into z plus 1. Okay, which is in the form of 2 by 3i integral over c f of z dz. Okay, hereafter we can apply our known procedure only. In step 1, find the residue for this equation. Before we find the residue, first we need to find the poles. Okay, in step 1, find the poles. If we equate the denominator equation to 0, we will get the poles. 10 by 3 z plus 1 is equal to 0. What is f of z here? F of z is 1 by z square plus 10 by 3 is z plus 1. Okay. Now we are going to simplify this equation. We need to find the roots, which is the quadratic equation. We know that the formula to find the roots for this equation, which is minus b plus or minus root of b square minus 4ac by 2a. Here a is 1 coefficient of z square, b is 10 by 3 and c is 1. Okay, substitute in this formula. Z is equal to minus b minus 10 by 3 plus or minus root of b square 100 by 9 minus 4ac. 4 into a1 b also c also 1, which is 4 only, by 2a, that is 2, minus 10 by 3 plus or minus root of taking cross multiplication, it will be 100 minus 36 by 9 divided by 2. Okay, now minus 10 by 3 plus or minus root of 100 minus 36 will be 64 by 9. Okay, into 1 by 2. You can write here minus 10 by 3 plus or minus root 64 will be 8, root 9 is 3 into 1 by 2. Okay, this can be written as minus 10 plus 8 by 3, one term. The another term is minus 10 minus 8 by 3. Because the denominator values are same, no, we can add the numerator term directly into 1 by 2. Here 1 by 2, here 1 by 2. Okay, minus 10 plus 8 will be minus 2 by 3 into 1 by 2. Second term is minus 18 by 3 into 1 by 2. We can remove this 2, we'll get minus 1 by 3 here. Here it is 9 and then 3 comma minus 3. Okay, minus 3 and minus 1 by 3 are the roots. Now we can write this is the quadratic equation only, we are getting 2 roots only. Now we can say that here minus 1 by 3 and minus 3 are the simple poles, because the power value is 1 only. Quadratic equation we are getting 2 roots, and then we are going to check whether lies inside the given image or not. Okay, the given image is modulus of z is equal to 1, which is on a unit circle. We know that z is x plus iy equal to 1. Remove this modulus. We can write x square plus y square is equal to 1. Squaring on both sides, we get x square plus y square is equal to 1. Equation of circle only. Center of the circle is 0, 0 and radius will be 1. And then draw the diagram. Center 0, 0 and radius 1 here, x-axis, y-axis. Okay, now we can write here minus 1 by 3 obviously lies inside the image only, because radius 1 means we can write here minus 1 by 3. Minus 3 this side will come, obviously lies outside the modulus of z is equal to 1. Now write here. Here z is equal to minus 1 by 3 lies inside the circle modulus of z is equal to 1, and z is equal to minus 3 lies outside the circle modulus of z is equal to 1. Okay, now we are going to find the residue only for z is equal to minus 1 by 3. Okay, which is a simple pole only. Using simple pole residue formula, we can easily find the residue. We know that the simple pole residue formula, which is limit z tends to z naught, z minus z naught into f of z. Okay, here we can take z is equal to minus 1 by 3, substitute here, limit z tends to z naught, z minus of minus 1 by 3 into f of z. What is our given f of z here? Here f of z is, we have taken this equation now, this is f of z. 1 by z square, 1 by z square plus 10 by 3z plus 1. Okay, now we can write limit z tends to z naught is minus 1 by 3, substitute here, z minus of minus will be plus, z plus 1 by 3 into 1 divided by, this quadratic equation can be written in the form of z plus 1 by 3 into z plus 3, because these are the, here what are the roots? The roots will be minus 1 by 3 and minus 3 only. We can write in this form. If we multiply these two equations, two terms, we will get this equation. Okay, now we can remove these two terms and then apply the limits here. Z tends to minus 1 by 3. 1 by minus 1 by 3 plus 3 is equal to, we can write minus 1 plus 9 by 3 equal to 1 by minus 1 plus 9 will be 8 by 3. 1 by 8 by 3, this can be written as 3 by 8. The denominator 3 goes to numerator. Now we can write 3 by 8. Therefore, where the residue is 3 by 8. And then using Cauchy residue theorem, we can write the final answer. We know that the statement for Cauchy residue theorem, which is integral over C f of z dz equal to 2 pi I into sum of the residues. In this problem, we are having only one residue. That's why you can write integral over C f of z dz is equal to 2 pi I into only r. Here f of z is dz by z square plus 10 by 3 z plus 1 equal to 2 pi I into r. Residue is 3 by 8. Substitute here. And also, before this f of z, see, look at this. Before this f of z, we have 1 2 by 3i here. 2 by 3i. We have to multiply with the 2 by 3i here also. 2 by 3i integral over c z by z square plus 10 by 3 z plus I equal to, in the right hand side also, multiply with the 2 by 3i. 2 by 3i into 2 pi I into 3 by 8. Okay, now we can remove this 3 here, I, and also 2 here, 4 2s are 8. Again we can remove this 2, 4 2s are 4. Therefore, the final answer is 5. That's all.